When I first read the telemetry report from China's Tianwen-1 spacecraft, I paused for a long moment, not because the numbers surprised me, but because of what they represented. A fresh set of eyes on the most mysterious object currently moving through our solar system, 3 Atlas. For the first time, data on an interstellar visitor comes not just from Western agencies like NASA or ESA, but also from a Chinese probe orbiting Mars. And that in itself is remarkable. At a distance of about 30 million kilometers, Tianwen-1's imaging payload captured extremely high-resolution data about an object we've been obsessively tracking for months. An object that's challenging our expectations of how matter behaves near a star. You see, when you look at 3 Atlas through a telescope on Earth, you're looking through an ocean of atmospheric turbulence. But from Mars orbit, Tianwen-1 has a clear view. Mars' thin atmosphere and its orbital perspective provide a clarity unmatched by any ground-based telescope. And in that clarity, we're now seeing details that defy the very definition of what we call a comet. Let's rewind to one of the mysteries that is making the astronomy world boil. 3. I-Atlas, the third interstellar object ever discovered by humans, is challenging all current understanding of the universe. Previously, Oumuamua had shocked the world when it appeared as a fragile, strangely rotating fragment with anti-gravity acceleration that could not be explained by the normal laws of physics. That discovery sparked a heated debate about whether this could be a natural object or the remnant of an artificial structure created by alien intelligence. Then Borisov appeared, and it was seen as the perfect model for a typical comet. Ice-filled, volatile, stable, and exactly as science had predicted at the time. Researchers thought they had found a benchmark to compare it to, a confirmation that not all objects from deep space were mysterious or irrational. But then 3I Atlas entered the picture as a paradox. It was a cross between Oumuamua and Boris, both like a regular comet and possessing unexplained strangeness from the moment it was first observed. 3I Atlas defied all expectations. Spectroscopic measurements showed it was emitting water vapor, while still far beyond the frozen boundary of the solar system, where in theory such evaporation should be impossible. This has led scientists to come up with a series of hypotheses. Could 3I Atlas contain an unknown physical mechanism, or perhaps traces of a strange compound not found in ordinary celestial bodies? Some bold researchers have even questioned whether this could be the remnants of an artificial structure that once drifted between the stars, or worse, a purposefully sent message from some distant civilization. Walking the thin line between science and speculation, 3I Atlas is becoming the focus of global curiosity. It is not just a strange object in space, but also a reminder that the universe still holds countless mysteries that have yet to be solved by humans. Mysteries that could completely change the way we understand life and intelligence in the vast universe. 3. I-Atlas's extraordinary discovery quickly sparked one of the largest international observation campaigns in modern astronomy. Leading agencies such as NASA, ESA, JAXA, and recently China's Tianwen-11 joined forces in an unprecedented effort to unravel the interstellar object's mysteries. This transcontinental collaboration not only demonstrates the scientific importance of 3I Atlas, but also reflects a global curiosity. Are we dealing with an extraordinary natural phenomenon or a clue sent from far away? Remarkably, the cameras on board Tianwen-1, originally designed to take ultra-high-resolution images of the Martian surface and atmosphere, have been repurposed by Chinese engineers to capture deep space exposures toward 3I Atlas. By reprogramming the optics, they have transformed a planetary research instrument into a makeshift space telescope sensitive enough to detect tiny changes on an object's surface thanks to advanced adaptive tracking technology. Tianwen-1 was able to precisely compensate for 3IA Atlas's apparent motion as it passed over the distant star background, allowing scientists to capture images of unusual sharpness. In those images, they detected subtle changes in the object's albedo, or how light reflects off its surface. These variations, though tiny, revealed important clues about the structure and materials that make up 3I. Atlas, could they be traces of unusual evaporation activity, the formation of exotic minerals under interstellar conditions, or something else going on inside its dark shell? As the data continues to be analyzed, the scientific community is facing a provocative question. Is 3I Atlas not simply a space tourist passing by, but a messenger bringing untold secrets about the world out there? And it is these subtle variations that tell a strange story almost incongruous with the known laws of physics. The data revealed that on the surface of 3I Atlas, there exists highly reflective, almost mirror-like regions interspersed with dark carbonary patches. This structure makes the surface of the object appear to be a composite of two different worlds. One bright, cold, and crystalline, the other dark, almost completely absorbing light. This image suggests that 3I Atlas may have undergone a process of partial melting, followed by a sudden cooling causing its crust to crack like a nail glass. For planetary scientists, this is not only a remarkable phenomenon, but also a puzzling paradox. An object that is believed to have drifted between stars for millions of years should have cooled evenly, its surface smooth and polished, and it should not have retained traces of melting or layering. The presence of crystalline reflections interspersed with dark carbon planes suggests that 3I Atlas may have a complex thermodynamic history, possibly due to intense radiation, high-energy collisions, or even some previously unknown form of internal reaction. Some researchers cannot hide their skepticism. Could it be that 3 Atlas is not entirely a natural fragment? The almost mirror-like reflection of the structure reminds many people of a man-made material, a synthetic compound that is heat-resistant and highly reflective. If so, is this the remnant of a ruined engineering structure drifting through space from a lost civilization? Or is this simply a rare coincidence of nature that the human imagination is trying to fill with conspiracy theories? Whatever the hypothesis, 3I Atlas continues to fascinate and alarm the scientific community. Each new image and spectrum sent back from international observatories seems to raise more questions than answers. And in that gap between science and mystery, 3I Atlas still drifts quietly, carrying with it an unfinished story about its own origin and perhaps about us. 1011's observation point is considered the key to opening a new chapter in the journey to decipher 3 Atlas from Mars' orbit. This unique observation position creates a perfect geometry between the sun, the object, and the probe, allowing the spacecraft to record forward scattered light and photons reflected from dust grains in space directly into the sensor. This type of observation is extremely rare because it can reveal the microstructure of matter, whether the surface of 3 Atlas is made of smooth ice, solid rock, or even reflective grains with metallic properties. The images sent back stunned scientists surrounding 3I Atlas's core was a faint halo that stretched for tens of thousands of kilometers. But unlike the familiar tail of a comet, it did not radiate away from the sun. Instead, the shell appeared to rotate on the object's own axis, forming a giant self-stabilizing plasma membrane. If confirmed, this phenomenon would be the first time in astronomical history that a comet has been shown to possess a uniformly rotating plasma layer completely different from all known models. The Harvard team's initial analysis after I shared the data all came to the same conclusion. We may be witnessing a rare magnetohydrodynamic coupling in nature, where the plasma is constrained not by light or heat, but by the object's own internal magnetic field. This doesn't mean that 3I Atlas is the work of an alien civilization, but it certainly suggests that it's a sign of extraordinary physical processes far beyond what we currently understand about comets. If 3I Atlas is indeed able to maintain a stable magnetic alignment in interstellar space, it would imply that it contains previously unknown materials or structures that are magnetically conductive or contain metallic particles locked in its ancient magnetic field. This is an extremely rare trait for any natural object that has wandered between stars for millions of years. When the Tianwen data was sent back to Earth, the China National Space Administration (CNSA) issued a brief but meaningful statement. Preliminary observations confirm a dynamic ionization structure unlike any known cometary object behind that diplomatic language. The scientific community read a more straightforward message. Something extremely unusual is going on, and perhaps 3I Atlas holes within it. The answer to a form of physics that humanity has yet to touch, or a secret that the universe has deliberately kept hidden for billions of years. One of the most remarkable things about this moment is that the spirit of scientific cooperation has been raised to a new level. The Cold War era, when space was a playground of confrontation and secrecy, seems to be a thing of the past. Instead, today, knowledge is being shared across borders. Sometimes discreetly, sometimes openly, but always with a common goal to uncover the mysteries of the universe. When the first frames of Tianwen-1 were released, NASA reacted immediately. The Solar Dynamics Observatory quickly compared ultraviolet readings to find a correlation between 3I Atlas's ionization and solar radiation. Almost simultaneously, the spacecraft's solar orbiter's team also began refining models of the comet's plasma and tail to determine whether the synchronous rotation phenomenon recorded by Tianwen-1 could be reproduced using conventional physics simulations. At Project Galileo, our team immediately fed this data into a machine learning system, an artificial intelligence network that is being trained to recognize the spectral characteristics of interstellar objects. The images from Tianwen-1 became valuable test data, helping machine learning better distinguish between the signatures of natural objects and artificial capabilities. This is a vivid picture of global science in the 21st century. Different tools, different philosophies, but the same fire of curiosity that drives humanity forward. I have always believed that the study of interstellar travelers cannot be the exclusive domain of any single nation or science, because the universe has no borders, and celestial bodies do not carry passports. If our goal is to understand our place in the cosmic picture, international cooperation is not only the smart choice, but the only way. Therefore, I particularly welcome China's decision to make part of the Tianwen-1 data public through the National Space Data Center NSSD. This not only demonstrates the openness of the Chinese scientific community, but also provides an opportunity for researchers around the world to verify, debate, and expand their analysis. In an era where humanity's big questions transcend borders, this can be seen as a symbolic step forward as science, instead of competing, becomes the common language that connects people on their journey to understand the universe. And then scientific evidence began to reveal a story much more complicated than anyone had thought. Spectroscopic data collected by Tianwen-1 recorded emission lines that matched the signature of hydrated silicate, a mineral that forms only when rocks are exposed to liquid water for long periods of time, along with traces of iron-nickel compound, which is commonly found in the cores of celestial bodies that have undergone thermal differentiation. These results, if confirmed, would have huge implications. 3. Atlas does not appear to be a primordial chunk of ice drifting through space like classical comets, but may have once been part of a differentiated celestial body like a planetesimal or even a small moon. That means that in the distant past, this object belonged to another star system, one with enough heat and gravity to create its distinct structural layers, a metallic core, a rocky mantle, and an icy surface.